Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have square root of n plus n equals to n times of square root of n. And now we solve this problem for the values of n. So here you remember one thing is that our n is must be a positive number. So the very first step we are going to do is here first we take this square root of n equals to y. So when you take square root of n equals to y, then the above expression will be written as so this implies that when we take a square on both of the sides, so you get here y square equals to n. So now we substitute square root of n equals to y, and n equals to y square in this equation, so it will becomes y plus y square equals to, we have n and it is equals to y square, and this equals to y. So now we simplified the terms, and we write it as y plus y squared equals to y square times of y becomes y cubed. And now we rearrange the terms and we move this y and y squared to the right hand side, and it will becomes y squared minus y cubed minus y squared minus y equals to 0. And here you see that we have uh, y be the common term, so that we take common y here and we obtain y squared minus y minus 1 equals to 0. So in the next step, here we further divide this into cases, so that our first case is we take y equals to 0, and the second case is we take y squared minus y minus 1 equals to 0. So now in the next step, here we get the one value of y here. So now in order to find the other values of y, we need to solve this quadratic equation, so that here we use the quadratic formula in order to solve this equation. So now first we write the coefficients of this equation, and the coefficients are a equals to 1, b equals to minus 1, and c equals to minus 1. And our quadratic formula will be written as y equals to minus b plus minus square root of b squared minus 4 times of ac divided by 2 times of a. So here we substitute the values of b, a and c. So first we put the value of b, and it will becomes minus times of minus 1 plus minus square root of b square. So our b is minus 1, and minus 1 square is plus 1, minus 4 times of a is 1, and c is minus 1, and this whole square root divided by 2 times of 1, and 2 times of 1 becomes 2. So in the next step, we have this minus times of minus becomes plus 1, and plus minus square root of 1, and this minus times of minus becomes plus 4, this whole divided by 2. And now we simplify this equation, and we get 1 plus minus square root of 5 divided by 2. So here we make two cases. First we write the positive value, it is 1 plus square root of 5 divided by 2, and now we write the negative value, which is 1 minus square root of 5 divided by 2. So here we have other two values of y, and now we back substitute the values of y, and you see here we have y equals to square root of n. And now first we put the value of y here, and we get the value of n. So you get the square root of n equals to 0, and now we take the square on both of the sides, then you get the first positive value of n equals to 0. So this is because our n is greater than or equals to 0, so we have n equals to 0 be the first root of the given equation. And now in order to find the other roots, we need to solve this equation, and now here we again substitute the values of y. So this will become square root of n equals to 1 plus square root of 5 divided by 2. And if you focus on this case, in the right hand side we have a negative value, but we have a restriction in the start of the problem, is that our n should must be an positive number. So if it is negative, so we rejected this case. Because we need only positive numbers, so we proceed here this case only, and in this case we need to take square on both of the sides of this equation in order to find the values of n, so that we get square root of n and its whole square equals to 1 plus square root of 5 divided by 2 and its whole square. So now we make the square. So in the left hand side you see here these 2 and square root are gone, and we get our n equals to here we separate the square numerator and denominator, and it will be written as 1 plus square root of 5 whole square divided by the square root of 2 is 4. And now first we open the square of numerator, and it will be written as 1 square plus square root of 5 and its whole square plus 2 times of 1 into square root of 5, this whole divided by 4. And now here we need some simplification, and we obtain 1 plus these 2 and square root are gone plus 5, and this will becomes 2 times of square root of 5 and this whole divided by 4. So now for more simplification we write the next steps here, and you see that we have our n equals to 1 plus 5, and we know that 1 plus 5 equals to 6, so we write it as n equals to 6 plus 2 times of square root of 5 divided by 4. Okay, so we add 1 plus 5 is 6 and plus 2 times of square root of 5 and this whole divided by 4. So now we need more simplification, and you see here we first take common 2 from the numerator, and it will becomes n equals to 2 times of 3 plus square root of 5 and this whole divided by 4, and we cancel this 2 times of 2 is 4, and we get the other positive solution is 3 plus square root of 5 divided by 2. So this is the second positive solution of the given question, and our first solution is n equals to 0. So this is the our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.